All right, we're on the pi lesson, 314, literal equations, and we're going to be using pi today, and not just pi, but other letters. And I want you to notice in the box here, it's mostly letters, okay? And don't let that scare you. Math still works the same with the letters as it does with the numbers. You add, subtract, multiply, divide, the same. And so we'll start reading here. The word literal comes from the Latin word that means letters in the alphabet, okay? Or letter of the alphabet. So a literal equation in math refers to an equation which uses letters. And they have some examples, like circumference equals pi d, and area, and then this is the area of a triangle, is 1/2 base times height. Or if we have the perimeter, and this is of a rectangle, 2, and if you notice that looks kind of like a tilty thing, and I like to make an L like that so I don't get them confused with a 1, plus 2w, and so forth. Okay, all of these are literal. Now there's one more that actually has some numbers, and we did have a number right here, but we have some, and right in here, right?
Yep.
But most of them are going to have letters, okay? And we're going to be solving these today, okay? We're going to use the properties of equality, like that we can add, if we add the same thing on both sides or subtract, or if we divide on both sides. Those still work the same as they did with the equations to solve for numbers, but when we're done, we won't have just x equals 2. We'll have x equals or r equals, and we'll have that equals some big stuff. And sometimes it looks uglier than when it started. And it's a really good practice for you to be able to move these around. Okay. They're giving you some steps to follow. I don't know how well I like the idea of following just steps, but sometimes that's easier for some. But I like you to just know the why you do it, and then usually the steps fall into place because you understand why.
Yeah.
But let's at least read the steps. Let's come up here first too. Using the properties of equality, the variables of a literal equation can be rearranged. Following is the distance formula written several different ways. So here's d equals rt. This is just, some people call it the dirt equation. This is you find the distance equals rate times time. But if we move everything around, all right, but if we rearrange it, it could look like this. R equals d over t.
It's
the same equation, we just moved it around.
So now you're dividing.
Now we're dividing. But we could have also rearranged it, and d equals d over r. We're going to show you how to rearrange them today so that there's the same equation. And the reason I'd want it maybe to be done this way is that if I'm in the science that you might be doing, if you knew the rate and time, you could multiply to get the distance. But what if you didn't? What if you were looking for the rate? Well, if you're looking for the rate, then you divide the distance and the time.
Oh, and if
you're looking for the time, you divide those. Okay,
so far all I've been doing is that.
Right, and so if you wanted the other ones, then you know what to do to divide them. Right? And so, yes. So, let's get into it. I was just trying to see let's go here.
I think that's a good idea.
Sometimes transforming the literal equations is called solving the equation for another variable, although this process does not actually find any numerical value. So today, you're not finding like x equals 5, okay? We're not doing that. We're actually just rearranging the formula so that I can look for other variables when I can plug in to find other variables, okay? So let's do this one. We're going to do a equals 1/2 BH. That's the area of a triangle. And they're always going to tell you to solve for, and they're going to tell you a variable to solve for, b. And it's important. When I was first learning this, I was like, how do I know what to do? So they're telling you that they want to have b equals a bunch of stuff. Okay, so b will be on, and I always like to put it on the left side. You don't have to, but I always like to put it on the left side. And then all the rest of the letters and numbers will be over here, okay? And so that's
what I do.
So that means if we want to solve for b, then I ask myself, what do I have to move out of the way? Well, b's here with an h and a half, so I have to move the h and half to the other side.
So you'd have to divide.
Yes. And since we're multiplying the b and the half to, the h and the half to the b, then the opposite of that is to divide. And so you get to choose. Do you want to divide the half or the h first?
The h.
Let's do the h first. So we're going to divide by h. We're going to do the same thing we did with numbers. Okay? Divide and divide. Okay? This will reduce, leaving me with a b equals 1 half b. The h is gone. And now we just write it how it shows it right on this side over here. A over h. Okay?
That's it?
Not yet, because b is not done, because I still have the half there.
Right, okay.
With fractions, how do I divide with fractions?
You multiply.
By the
reciprocal.
Good job. So what's the reciprocal of 1 half?
2 over 1.
2 over 1. So we're going to multiply by 2 over 1.
And then 2 over 1.
We do it, and we have to do it over here. And when we do it the 2 over 1, this fraction line stays, and the 2 over 1, we don't have to write the 1, but we could. You know how a minute ago I just said that I like to put things on the left? Well, now this is on the right. I just contradicted to myself. Okay, these are going to... Okay. These are going to reduce. B's left by itself. Now, this is the part that people get usually confused with. How do I write this? Just leave it how it is. 2a. If you don't want the 1 there, you don't have to, but you can write it over h. Okay,
Got it.
And we're not really making it look prettier. In some cases, it looks
worse.
But we've solved for b. So now, if you knew the area, you knew the height, you could find the base of that triangle. Okay. All right? All right.
I like it the way it was already.
All right, we'll do another example. P equals 2L plus 2W. And they want us, oops, you know what? Let me move this up.
Solve for W.
Yes. So we're going to, and this is really important. If they don't give you anything to solve for, you can't do this. So you have to have this part.
So instead of adding, we'll multiply.
Yes, so we need to get rid of, we got to get W all by itself. So we need to move the 2L and the other 2.
So 2L times 2.
So do you remember when you had 2x, let's do it the other way. 5 equals 4 plus 2x. What do I move first? Because we have to get the 4 and the 2 away. What do I move first?
The 4.
The 4, right? So I subtract the 4. And then I have the 2x.
Oh.
So this becomes, in our case, 1. And then how do I get rid of the 2?
You divide.
You divide. This thing right here is the same thing.
So
okay?
you subtract 2, subtract 2, so then you'll have L and W.
We're going to subtract the 2L, this whole piece.
Oh.
Does that make sense? Because it'll go over there.
So then it'd be L over W, and so then you'll divide the L and the W? No, I mean the L over P.
Is this, what is L, excuse me, P minus 2L?
I don't know.
It's just P minus 2L.
Oh.
Can't do anything with it. Does that make sense?
Yeah.
And then we have the 2W.
Divide?
Yes. When I divide the whole thing.
So it'll just stay like that.
So it'll just, and so, again, I said I like to put on the left, but it's on the right. Contradicted myself. P minus 2L over 2, and that is, oh, no. Actually, this whole thing is the answer.
Okay. It's just going to take me time to remember you have to do everything.
Yes.
I want to just do numbers.
Yes, and you just want to do the numbers, but the L's goes with it, okay?
Okay. Let's do another one.
Yes. Let's do A, equals pi r squared, and we're going to solve
For all A?
in this
R.
case. It's already solved for A,
Oh, yeah, that's right.
so we're going to solve for r. Okay, so I've got a pi and a squared that I need to move off of it.
So you divide
Yes, by what?
by pi.
Good.
Divide by pi.
So this will be r squared equals A over pi. How do I get rid of the squared?
You multiply. No. You divide. Do you subtract?
Do you remember last year when you were doing your Pythagorean theorem and you had like a squared equals
You do the
16?
square
Yes, you do the square root.
Obviously, I wasn't looking at my paper.
That's true. Take the square root And then the square root and the square
R.
go away, and we just have R, and I'm going to do it, I said I like to put it on the left, I'm going to do that. And this just stays how it is. Square root, and make sure the square root's on the whole thing, top and bottom.
Okay.
Because some students make the mistake, and they
do like this.
They just do this little teeny one, and it's on the top, okay? But it's actually the whole thing. So R equals the whole big square root of A over pi.
Got it. I like that one the best.
There are a lot... Trying to see the difference between those two.
They just have one on this side, one, like the R on this side.
Like
right,
what
like
I
doing.
did. Okay, I see. Now, the part that makes this difficult for most students is there isn't like, when you were solving these kinds. You always move this first one. You always divide here. And there was like this procedure you could get through. This one has a little bit harder because depending on the problem means that you have to do it in different ways.
Yeah.
So you have what for me to make it helps me remember is I try to imagine a problem that was like this with some numbers. The ones that like I did with this one for you, I put out I put out that equation one.
Yeah.
Well, the ones like these are like is like one that I had 5 equals 2x like that. Okay, squared even. Okay, and so then I have to move the 2 over by dividing, and then square root. Okay?
Yeah.
So you've had problems like this with numbers, but then when you're looking at it with all letters, some students go, uh-oh, and they don't see that it's familiar in any way, but you actually have done these in problems that look like this.
Yeah.
And when they're all letters, it doesn't look familiar to you.
Right.
And similar to the one we had down over here, this one we've had before, where you might have had a couple numbers together where you could multiply them together, or fractions where we did the reciprocal. You've done all this, but not with just letters. Let's see what they got here with...
hopefully not a lot.
Fine.
Oh, yes.
And so the nice one that they have here, this A equals 1/2 BH, you just did this one, except we solved for B instead of H.
Oh, okay.
So if we solve for H...
You're still going to do the same thing because it was still... So you're still going to divide.
Yes. So we're still going to divide. We're going to keep H there. We're going to move the B in the half. What are we going to get rid of first?
The B.
Okay. And we're going to divide, you said, I heard. So H is going to equal... No, half H is going to equal A over B.
No, just divide by the reciprocal.
Yes.
Or multiply by the reciprocal, I mean.
That'll cancel. Leave you with 2 over 1 over here. So H, doesn't matter what side we write it on.
Equals 2A over B.
Yes. Okay.
Yeah, these aren't that bad.
Not so bad. And let's do one like this one. Okay. Let's do V equals B over H divided by 3. This time we're going to solve for B.
Are you just going to do the reciprocal? No, we're going to do that thingy-majig, the square root thing.
What do we have to get rid of over here?
The H.
And the
B. 3, I mean.
Yeah, what do you want to move first?
The 3.
Okay, how are we going to move the 3?
You're going to multiply.
Okay, so I'm going to multiply by 3 over here, which reduce, and multiply by 3 over here. You with me so far? 3V equals BH. Where do we have to move now?
The H.
And how are we going to do that?
Divide.
Okay. And I'm going to have B. And what is this going to become over here?
3B over H.
Good. No square root at all?
Yeah, where did I get square root?
I'm not sure. I'll do it though. Let's do one of these. Okay. And I'm going to make up new numbers, okay?
Oh, man.
I'm going to say 2x equals 5y minus 18, okay? And they said we're going to solve for y. Okay. We got to get the 5 and the 18 away. Which one do you want to do first?
The y. No.
We have to keep the y, and we have to get rid of the... Did I say y? I meant 5 and 18, whatever I said.
Oh, okay. Sorry. The 5.
Okay. How are we going to get rid of the 5?
You're going to no, you're not. To multiply. No, you're not. You're going to do the square root thingy, right?
No. If you had an equation that looked like this, 5 equals 7x plus 12.
You're going to multiply.
What would I... This is a 5, it's supposed to be.
Because you would do the thing where you move it over.
Yes. What am I going to move over first on this one?
You're going to move over the 5.
We're solving for x.
Oh, you're going to move over the 12.
Yes, I'm going to subtract 12 over to here, right?
Yes.
Once I do that, I'm going to divide by the 7, right?
Right.
Okay. So, on this one...
You're going to move your 5 over and subtract from 18.
Okay, so which one am I going to do first? The 18 or the... Excuse me, the 18 or the 5?
18.
Okay, how am I going to move the 18?
No, move the 5.
You were right about the 18.
I was, but it doesn't seem like it'd be as nice.
Well, you have to, because when you divide, you got to divide everything by 5, and so we need the 18 over
right.
first.
Yeah, so we need to get 18 over. And you'll bring it over underneath. No. Yeah. No. Hold on.
What is 18 doing to the y? Is it adding, subtracting, multiplying, or dividing?
Multiplying.
So this is y times 18 right now?
No. You can't do anything to the y with it, though.
Well, because right now this is 5y, and you're subtracting 18. So to move it to the other side, I have to add.
Because you're subtracting.
Are these like terms?
No.
Okay, so if they're not like terms, all I can do...
Plus 18 equals 5y. Now you can get rid of the 5.
Yes, and I'm going to suggest with these type, because we're going to do that in a little while, you're going to use this to start graphing later. You could just do this, but to make it simple for what we have to do later, I'm going to have you do this. Okay?
Okay.
And you're going to, whoa, I'm going to have to do this. I'm going to move this. We're going to copy, because we don't have enough room, and I want you to be able to see what was there before, okay? We're going to, okay, so then when you're going to write your answer as y, you can put the y equals here or the y equals there, it doesn't matter. 2/5 x plus, and if this can be reduced, do.
Okay.
Okay? 18 over 5.
Okay.
Okay? We're going to use these pieces later for something else.
Okay.
Okay?
I just need to remember you can add. I always think that you can't add. I think you can either divide
because we
or
haven't
multiply.
done any of those. Most of the ones before now we've been dividing and
multiplying.
stuff,
That's why I keep thinking I can't
not adding.
add.
You're right. So this one we can. We can add and subtract. We hadn't been doing a lot of that, so that makes
Yeah.
sense. Okay?
Okay.
All
It's
right.
not hard. I just forget you can add.
Right. Exactly. Okay? And so these, and I'm cautious to tell you that things are difficult because I don't want you to feel like, oh no, I can't do this. But I don't want you to get the whole idea that, man, this is so easy and I'm having a lot of trouble. So if you start having troubles on these, I want you to realize this isn't easy stuff. That doesn't mean it's not, you don't have the ability to do it, but it means that you shouldn't feel dumb if you don't get it. Okay?
Okay.
All right? So you can do it, but you might have to practice a little extra. And because everybody has trouble with these, not just you. So I don't want you to feel alone. Okay?
Right.
We're done.